Today, I'll explain the basics of regression analysis using the scatter plot in Excel. Hi, this is Mike Negami, Lean Sigma Black Belt. Our topic today is from this request. Please explain multiple regression analysis and correlation that can be used in business forecasting and customer satisfaction research analysis, etc. Thank you, Kat Aldi, for your request. In order to answer his question, I have to explain the basics of regression analysis first, so I divided this topic into 3 videos. This video is about doing a simple regression analysis with a scatter plot, and the second one will be about doing a simple regression analysis with the Excel data analysis tool. Then the last one will be about the multiple regression analysis. These days, with the development of IT, most companies can gather a lot of data. That data is the result of your business activities. Regression analysis gives us good hints about the causes of the business activities and factors that affect those results. The real purpose of analysis is to use them for your future activities. It's true for any data analysis that you cannot stop with just making them. Regression analysis already sounds complicated. I thought that it's easier to understand simple regression analysis by learning from an actual experience that I had. I regularly post articles on my blog, econoshift.com. First, I write a blog post and then make a video about the same topic. I wanted to predict video duration from the number of words on the video post. I gathered 10 sets of sample data of the number of words in past blog posts and their video durations. The video duration I want you to predict is y, which is called the objective variable, and the number of blog words is x. That should be written as a factor, and this is called an explanatory variable. From a simple regression analysis, we can express the objective variable by the equation y equals ax plus b. This expression is called a regression equation. For my data from the result of the simple regression analysis, it becomes y equals 0.47x plus 35.5. The 0.47 portion is called a coefficient and represents the slope of the line of the regression equation. For my equation, if x increases by 1, y increases by 0.47. Also, the plus 35.5 portion is called an intercept and represents the value of y when x is 0. From my equation, if the blog has 600 words, x is 600, 0.47 times 600 plus 35.5 equals 5 minutes 18 seconds. I can predict video duration quite accurately with this, and it's very helpful. In this example, since there is only one explanatory variable, it's simple regression analysis. When there are 2 or more explanatory variables, we'll use multiple regression analysis. The multiple regression equation looks something like this. Because I want my video to be about 5 minutes, I always check the video duration with this formula before I film my video and utilize the result to decide whether to add more content or sometimes divide the content into 2 videos. In fact, I divided today's topic into 3 videos because of this equation's result. Let's do the simple regression analysis with Excel. Before doing a simple regression analysis, it's good to make a scatter plot first and visualize the data. Simply select the source data and select Insert, and then in the chart section, select Scatter. It seems that the data have a positive correlation. However, the objective variable, which is the video duration, should be on the vertical axis, but here they are reversed. Click on the Design tab, the Select Data, then edit and switch around the data groups. Next, in the same Design tab, select Add Chart Element, Trend Line, and more trend line options. On the right screen, select Linear. Try to select other models. As you change the selection, the line on the chart also change. If other models are better fit than linear, it's better to use that. I'll use linear this time. Then check display equation on chart and display R-squared value on chart. Now a regression equation has come out. What is this R-squared value? This is also called the coefficient of determination. There is another similar concept which is called correlation coefficient. Lastly, I'll summarize these confusing terms clearly. The correlation coefficient is a numeric value between -1 and +1, and the closer it is to -1, the stronger the negative correlation, like this. The closer it is to +1, the stronger the positive correlation, like this. The R-squared value and coefficient of determination are the same thing, and it's the squared value of the correlation coefficient. So it will be a value between 0 and 1. It represents that the closer it is to 1, the more accurately the regression equation can calculate the objective variable. Thank you very much for viewing. Please click the subscribe button. Also, click and watch my other related videos. Thanks.